Hello friends, welcome to our channel. In today's video, we are going to learn how to solve remove duplicates from sorted array. So let's see. So as you can see, this problem comes under easy category. Let's see if it is that easy. Okay, so what is given to us? First, let's read the problem statement. So what is given to us? Given an integer array num. So basically we have been given an array sorted in non-decreasing order. So the array is sorted. Remove duplicates in place such that each unique elements appear only once. The relative order of the elements should be kept the same. So their order should not be changed. They should be in the same order. The return the number of unique elements in the array. So in this array, we have to return the unique elements present. So there are duplicates in that array and the array is sorted. So let's see. Consider a number of unique elements of nums to be k. Suppose there are k unique elements in an array. You need to do the following things. What we need to do in this code, let's see. Change the array such that we have to modify the array such that first k elements of that array contains the unique elements in the order they were present in array initially. So we have to modify the array such that all unique elements come in the start of the array without changing their order. The remaining elements of the nums are not important as well as the size of the array. So basically, what are the number of elements present at the end? They don't care. They all need the value of k, that is unique number of elements, and place it in the initial of the array. So they will automatically, if you pass that value, they will automatically print from that array. So what is happening? Let's see. Custom just. So what they are doing? They are taking input array and they are expecting some array with correct length. Now k will have remove duplicates function which will call our implementation, and it will just for loop from first position of the array to the kth position. So that first to kth position should have all the unique elements. Okay. So let's see few examples given to us below. See, so input below is 1, 1, 2. The array should modify such that 1, 2, and after that, even if the number is present or you remove the duplicate or you place it at the end of the array, it doesn't matter. What they have to do, bring all unique elements in line in the initial state of the array. And output is 2. So we have to send the output as 2 and automatically that array will get displayed. Let's see another example. What is given to us? 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 4. So what you have to do? The first 5 elements should be 0, 1, 2, 3, 4, and they don't care what is at the end. Even if it is the same number or that initial number has been moved back, they don't care. Just send me the unique number length. So that is the question. Okay, so our function should return 5 with the first elements of array being 0, 1, 2, 3, 4. And remember, we don't have to create new array. We have to just modify that array and tell the number of unique elements. And then they will call their function on the same array and it will print the unique elements. So let's see how we can solve this question. So let's move to the whiteboard. So for explaining, I have taken this example. So let's see how we can solve this problem. So basically, the first thing given to us is array is sorted. So that is very important point, that we have a sorted array. Okay. Now how we can approach this sorted array question? So most of the times whenever the array is sorted, we use a 2-pointer approach. So let's see if we can use a 2-pointer approach over here. Okay. So what I'll do, I'll point to this first element, let's say I. Okay. And now I'll check with all the next elements after it, whether I'll initialize I to the first position, that is I is equal to 0. Let's do that. I is equal to 0. Then I'll initialize another pointer, let's say J. It will be at first position. So this initialization has been done initially. I is equal to 0, J is equal to 1. Now what we will do, we have to check if both the elements are equal or not. Okay, let's see. We have to check if nums of I is equals nums of j. Basically, we are finding duplicate. Are they same? Yes. So let's just move ahead. Our j. So we will move our j over here. Okay, what we did? We did j plus plus. Okay. Now, can you see nums of I is equal to nums of j? Is 0 is equal to 1? No. So, what we can do? So, this is the first element, unique element 0. After that, we found duplicate. We have to replace this duplicate with this unique j value. So, let's first increment our I to this position. I'll increment the I to this position. First, we have to increment the I. Then put that j value in the I. Num of I is equal to num of j. This done. Then again we have to. So what it will give me? It will be 0. Now I was I plus plus. So it will go at first position. So it will be here. I'll replace it with 1. Here 1 will be as it is. Again 1, 2, 2, 3, 3, 4. As you can see, I replaced the first position value with the j value. Okay, now we need to move further. So I'll do j plus plus. So now my j will be at this position. Is my num of I is equals to j, is 1 equal to 1? Yes, then just increment the j. I'll increment the j. Is nums of I is equals nums of j, I and j 1, 1? Yes. Then what we do? Increment the j. Is nums of I equals nums of j, 1 and 2 are equal? No, they are not equal. So what we will do? We will first increment the I. Increment the I will be I. Will come at next position. Now what we have to do after coming next position? Just replace this value with this value. So what we are gonna do? 0, 1, 2, 1, 1, 2, 2, 3, 3, 4. This is how array is gonna look now. My I is at this position and j is at this position. After replacing I, replacing value at I, what we will do? Again, we will increment the j. So let's increment the j. Is ith value and j's value are equal? Yes, 2, 2. Again, increment the j. 2 and 3 are equal? No, they are not equal. So what we will do? We will increment the I and we will put, I'll just erase it and write. I'll just replace this one with 3 and so the next array will be, I'll write over here 0, 1, 2, 3, 1, 2, 2, 3, 3, 4. Okay. So now my I is at this position. J is at this position. What to do again? Increment the j. Again I incremented 3 and 3 are equal. Again increment the j. What I'll do? 3 and 4 are equal? No. Then increment the I. Replace the j with, replace the I with j. So it will be 0, 1, 2, 3, 4, 2, 2, 3, 3, 4. And now my I will be here, j is at this position. Now can we go further? No. So this loop, I'll erase some, I'll write it over here once again, how it will look like. 0, 1, 2, 3, 4, 2, 2, 3, 4. I is here, j is here. Now can the j will go ahead? No, we have reached the end of the array. So we have to stop this. So how long it should go? While j is less than num dot size. That is till the end of the array. This implementation should be done. Now can you see our array is sorted, right? 0 to 4. Is there anything remaining now after reaching to the end of the array? No. So now the array is sorted. Now we have to return the size of that unique element arrays. So as you can see, our ith is at 0, 1, 2, 3, 4th position, and we have to return total number of unique numbers. So what we will return after this is return. What we should return? Return I plus 1. What is the value of I? 4. And if you do 4 plus 1, it will give n number of unique elements. That is 5 unique elements, right? 1, 2, 3, 4, 5. So just return the I plus 1. And once you return this, they will implement a for loop which will start from int I is equal to 0 to I less than k I plus plus. There their I value will be 5. And print array of I. So if you print, you will get 0, 1, 2, 3, 4. That's how it is implemented at their side. So you see how easy this question was. The only thing is you need to understand its logic. Like if they are equal, then just keep on incrementing the second pointer. If they are not equal, then first increment the first pointer, replace the first pointer value with the second pointer value, and again increment the second pointer. This should keep on doing till you reach the end of the array. And when you reach the end of the array, you have sorted all the unique elements and just return the first pointer plus 1 value back to the program. This is how you will solve the problem. Now tell me, what is the time complexity and space complexity of this code? So since you can see there is a while loop which is going till end of the array, and we have if and else inside that. So time complexity will be O of n. Did we use any extra space to solve this question? No, we just used 2 pointers. So space complexity will be O of 1. So time complexity O of n, space complexity is O of 1. So we can say that this is a optimal solution. This is how you will approach a remove duplicates from a sorted array. Now let's implement this code in our Leetcode. So let's go back to that Leetcode question again. So let's solve. So what we have to do, just initialize first pointer I with equal to 0, j equal to 1, okay. Then while j till it reaches the end of the array, so nums dot size. Okay, now what we have to check first, if nums of I equal nums of j. If they are equal, then what we have to do, just increment the j, that is j plus plus. Else what we have to do, else I plus plus, then what, replace nums of I with equal to nums of j. Once that is done, then do j plus plus, and then we have to just return I plus 1. Let's see if this get all test cases pass. Sorry, yeah. So as you can see, all test cases are getting passed. The output will not give you the value of unique elements. It will directly give you an array. But while returning, you have to return the number of unique elements. Okay, so let's see, all test cases are passed. Now let's see, can we submit this code? After submitting, all test cases should get passed. Yes, so as you can see, all test cases are getting passed. And now let's see this code again. Now if you see properly, I am incrementing j even if it is equal to nums of I, or even if it's not equal. Like in both the scenarios, I am incrementing the I. So incrementing the j. So does it make sense to write it 2 times? So I'm just like optimizing this code, nothing else. Like it should be a clean code. So what we can do, let's take this j plus plus outside. So see, in this if, what we are doing, just incrementing the j. So instead of that, can we modify this else like this? If nums of I, this is equal, right? So here instead of this we will write if nums of I not equal to nums of j, then do I plus plus. Now we have to do j plus plus no matter what. So let's remove this j plus plus outside this if loop and write it like no matter what, you have to keep incrementing the j. J will keep moving ahead even if the elements are equal or they are not equal. Okay. And now let's see. Same code, but the way of writing this code is different. Like if you see, the number of lines got reduced, but for understanding purpose that has to be done first, because when you will, like you are doing mathematically, you will do that way. But when you want to optimize your code, then this is the right approach, I feel. So if you run this code, we did same thing, but just the way of writing the code is little bit different. As you can see, all cases are getting, test cases are getting passed. Let's see if we can submit this code. So yes, this has been accepted by the Leetcode. So this is how you can solve the question. Even the previous way of writing is also correct. This is also correct. I'm not telling that it was wrong. Just this is another way of writing the same thing. So I hope you understood how to solve this question. If you have any doubts, let me know in comment section. And thank you for watching this video. Let me know if you have any doubts. Thank you.